at section 3.4, rational numbers. A rational number, called rational because it's a ratio, is just a fraction where the numerator is an integer and the denominator is a non-zero integer. It can be represented in many ways. A simple integer such as n, written as a fraction of two integers, n divided by 1, this is a rational number. Its most basic representation a rational number is an integer divided by a non-zero integer, such as 3 divided by 12. Fractions may be used to represent parts of a whole. The denominator is the total number of parts of the object. The numerator is how many of those parts are being used or selected. Another representation of rational numbers is a mixed number, such as 2 and 5/8. This represents a whole number, 2 in this case, and a fraction, the 5/8. Rational numbers may also be expressed in decimal form, for instance, 1.35. When 1.34 is written, the decimal part, 0.34, represents the fraction 34 over 100. The number 1.34 is equal to 1 and 34 100ths. Okay, got this. 34 100ths. However, not all decimal representations are rational numbers. Number written in decimal form where there is at least, or there is a last decimal digit after a given decimal digit. All following decimal digits are 0 is a termination decimal, as in 1.34. Everything beyond the 4 would be 0 if we continued it on. Another class of numbers that is not rational is the square root of integers or rational numbers that are not perfect squares, such as the square root of 10 or the square root of 25/6. Generally, the number b is the square root of the number a if a equals b squared. And the notation for this, b equals the square root of a, where the symbol here is the square root sign. An integer perfect square is any integer that can be written as the square of another integer. A rational perfect square is any rational number that can be written as the fraction of two integers that are perfect squares. So, determine if the following are perfect squares. The easiest way, of course, to do this is your calculator. Your calculator should have a button with the square root symbol on it. In the case of mine, the button is the square root, or the square, and then above it is the square root. So we'd simply go square root of 94 is 9.69, on and on. So no, this is not a rational number. Whereas the square root of 441 comes out to an even 21. So yes, this is. Okay, now determine which of the following are rational numbers. Well, the square root of 13 is not. It's not a perfect square. Now this notation, we have negative 13.21. The line over it means it continues. It repeats 2, 1, 2, 1, 2, 1, and keeps going. Therefore, we can say it's not a rational number. Now, negative 48 over negative 16, we do the division. This turns out to be 3, which is a rational number. And then negative 4 divided by 18 over 19, and -4 and 18/19. If you look at 18 divided by 19, it's a fraction, it's a decimal that doesn't end, so this is not. This, however, does end, so this is. So the fractions 3/5 and 9/15 are equivalent because they represent the same portion. We can loosely refer to them as being equal. The understanding of equivalent fractions is very useful for conceptualization, but it isn't practical in general. For determining when two fractions are equivalent, generally to determine if two fractions a over b and c over d are equivalent, we check to see a times d equals b times c. These two products are equal, then the fractions are equal. So we take 8 times 26, and we get, I have 8 times 26, which is 208, and does that equal 14 times 12, which is 168? Well, that's not equal, so no, they are not equivalent fractions. If you recall, our common divisor or common factor of a set of integers is one that divides all the numbers of the set of numbers being considered. In a fraction, when the numerator and denominator have a common divisor, that common divisor can be divided out. This is often called canceling the common factors or simply canceling. The process can be used to divide out common factors in a fraction. It's called reducing the fraction. If the numerator and the denominator have no common positive divisors other than 1, then the rational number is in lowest terms. The process of dividing out common divisors of the numerator and denominator of a fraction is called reducing the fraction. One way to reduce a fraction to lowest terms is to determine the greatest common divisor of the numerator and denominator and divide out the GCD. Another way is to divide out common divisors until the numerator and denominator have no more common factors. So let's look at these two methods with this term, 252 divided by 840. So if I look at 252, I can factor out a 2, gives me 126. I can factor out another 2, gives me 63. I can factor out a 7, gives me 9 left, and 3 and 3. Looking at 840, well, again, I can factor out a 2, leaving 420, another 2, leaving 210, another 2, leaving 105. 1 plus 5 is 6, so 105 is divisible by 3, and that's 35. And then 35 is 5 times 7. So get this out of here. So now what numbers do I have in common? Well, I have a 2 and a 2 and another 2 and another 2. I have a 7 and a 7. I have a 3 and a 3. I have 2 times 2 times 7 times 3, which is 84. So if I take 252 and divide it by 84, I end up with 3. And if I take 840 and divide it by 84, I get 3/10. Now let's look at this the other way. So we're starting out with 252 over 840. Now I can see they're both even. So divide both of them by 2. I get 126 over 420. Again, I can see they're both divisible by 2. Divide out 2. 63 over 210. Okay, now I can see they're both divisible by 3. 21, 70. Okay, now I can see they're both divisible by 7. 3/10. Same answer. Either method is acceptable, and as you see, we got the same answer. So what about adding and subtracting rational numbers? This can be done with a calculator, which often returns decimal representation, or by finding a common denominator for the rational numbers being added or subtracted. Looking at this one, I don't see anything common here. So we can simply use our calculator and do 124 divided by 297 plus 3 divided by 125. Now, the interesting thing about these calculators is they know PEMDAS. I get 0.4415084175. So that brings us to our formula for adding rational numbers. If C is a non-zero integer, then A plus C, or A divided by C, plus or minus B divided by C, simply A plus or minus B over C. So if we have a common denominator, we just add the numerators. So 38 over 73 plus 7 over 73 is simply 45 over 73. 21 over 40 minus 8 over 40 is 21 minus 8 over 40. However, when rational numbers do not have common denominators, then we have to transform the rational number so that they do have common denominators. A common denominator that reduces work later in the problem is called the least common denominator of the numerator and denominator. When adding or subtracting rational numbers, a over b and c over d, we perform the following steps. Find the least common multiple of b and d. Calculate n equals the least common multiple of b of d times b, or divided by b, and m, which is the least common multiple of b and d divided by d. Then we simply multiply the numerator and denominator of a over b by n, yielding a times n over b times n. And multiply the numerator and denominator of c over d by m, yielding c over m, or c times m over d times m. Then we can add or subtract because we have a common denominator. So I'm looking for the least common multiple of our denominators, 9 and 12 in this first problem. 9 times 2 is 18, 27, 36. Those are my multiples. 12, and then 24, and then 36. So my LCM here is 36. So 36 divided by 9 is 4. So we're going to take 4/9 and multiply by 4 over 4, which gives me 16 over 36. Now 36 divided by 12 is 3. So we're going to take 7/12, multiply it by 3 over 3, and I get 21 over 36. So now my problem simply becomes 16 over 36 plus 21 over 36, which is 37 over 36, or 1 and 1 over 36. Okay. This one's going to be a little more difficult doing this method. So we have simply, this is going to end up being 9,900. Nope, not even. This is going to be, yeah, 9,900. Going to multiply this by 100 over 100, and this by 33 over 33. Now 100 times 10 is 1,000 over 9,900 minus 17 times 33, which is 561 over 9,900. And we end up with 439 over 9,900. And if this truly is the least common multiple, that should not reduce. And I don't see 3 won't work, 10 won't work, 2 won't work, 5 won't work. So we're probably golden. One way to visualize a fraction is as parts of a whole. But when the numerator is larger than the denominator, then the idea of parts of the whole seems not to make sense. Such a fraction is an improper fraction. That kind of fraction could be written as an integer plus a fraction, which is a mixed number. So rewrite 95 over 26 as a mixed number. Well, how many times does 26 go into 95 evenly? So we do our division, and I get 3.65, so forth. So now my whole number part is going to be 3. Now, if I take 26 times 3, I get 78. So if I take 78 out of 95, I'm left with 17 over 26. Now, how do we do this the other way? We rewrite the mixed number as as an improper fraction. Take the denominator, in this case 14, multiply it by the whole number, 9, and then add the numerator, plus 5. And that will be your new numerator. 14 times 9 plus 5. So our improper fraction is 131 over 14. So understanding what decimals represent is needed before addressing conversions between fractional form of a number 57 1,000. The decimal portion 0.557 is 557 divided by 1,000. To write any decimal portion of a number expressed as a terminating decimal, divide the decimal number by 10 raised to the power equal to the number of decimal digits. We had 3. So we did 10 to the third power, which is 1,000. Decimal representations may be very long. It's convenient to round off the decimal form of a number to a certain number of decimal digits. To round off the decimal form of a number to n decimal digits, examine the n plus 1 digit. If that digit is 0, 1, 2, 3, or 4, the number is rounded off by writing the number to the nth decimal digit and no further. If the n plus 1 decimal digit is 5, 6, 7, 8, or 9, the number is rounded off by writing the number to the nth digit, then replacing the nth digit by one more. So round 5.1082 to 3 decimal places. So we look at the nth digit, the third one. Then we look to the next one. It is less than 5, so we simply drop it. 5.108, and that is it. Okay. Next, we want to round 18.6298 to 2 decimal places. So we want to round it to the second decimal place. So we look at the third one. It's a 9. We're rounding up. So 18.6 and 2 becomes 3. To convert a rational number in fraction form to decimal form, use your calculator to perform the division. So we're simply taking 48 divided by 30 equals, and I get 1.1.6 on my calculator, and it is a terminating decimal. Okay, so how about converting a terminating decimal to fractional form may be done in the following way. Count the number of digits in the decimal part of the number. We'll label this n. Raise 10 to the nth power. Write the number without the decimal. The fractional form is the number with step 3 divided by the result from step 2. So convert 17.03347 to fraction form. So how many decimal places do we have? 1, 2, 3, 4, 5. So 10 to the fifth. Well, 10 to the first is 10. 10 to the second is 100. 10 to the third is 1,000. 10 to the fourth is 10,000. So 10 to the fifth is 100,000. 100,000. And then we simply write our number out without the decimal. And that is it. Okay, so now let's look at multiplying and dividing rational numbers. Multiplying rational numbers is less complicated than adding or subtracting rational numbers, as there is no need to find common denominators. To multiply rational numbers, multiply the numerators, then multiply the denominators, and write the numerator product divided by the denominator product. So if b and d are non-zero integers, then a divided by b times c over d equals a times c over b times d. So this is simply 45 times 28 over 88 times 75. 45 times 28 equals 1,260. And 88 times 75 equals 6,600. Now, it doesn't say anything about reducing it, so I wouldn't go through the trouble, but it definitely can be reduced. I can see 10 easily, but we'll come to that later if it comes up. Okay, now we're going to use our calculator to calculate this and round to 3 decimal places if necessary. 45.63 divided by 17.13. And the number my calculator shows is 2.663747,811. And we want to round to 3 digits. So this is my third digit. So I look at my fourth digit, and it's 5 or greater, so I round up. So it becomes 2.664. And that is it. Okay, so before discussing division of fractions without a calculator, we should look at the reciprocal of a number. The reciprocal of a number is 1 divided by the number. So 1 over n if the number is n. For a fraction, however, the reciprocal is the fraction formed by switching the numerator and the denominator. For the fraction a over b, the reciprocal is b over a. An important feature for a number and its reciprocal is that their product is 1. When dividing two fractions by hand, find the reciprocal of the divisor, the number that's being divided into the other number, or in the standard form, the second number. Next, replace the divisor by its reciprocal and change division into multiplication. Then perform the multiplication. So as I said, A over B divided by C over D is equivalent to A over B times D over C. And that is our formula. So here I would simply change this, keep my 46 over 175, change the multiplication, and take the reciprocal of the second term, and then just do the multiplication. 46 times 285 divided by 175 times 69. 46 times 285. And this is 13,110. 175 times 69. And this is 12,075. And again, it doesn't say to reduce, so we'll hold off on doing that. And that would be our answer. Okay, let's look at another one here. So again, I have 3 over 40 divided by 42 over 55. So I rewrite this as 3 over 40 times 55 over 42. And then I multiply 55 times 3, 165, and 40 times 42, 1,680. That is what we're looking for. Okay, so the order of operation for rational numbers is the same as for integers. So again, looking at here, we have PEMDAS we're going to use. We're going to do what's in the parentheses first. So we're going to add this here. It's going to be 3 plus 7, which is 10. And there's the common denominator 16, so we're good. Squared plus 1/5 divided by 3/10. Then we're going to square 10/16. Well, squaring it is simply saying 10/16 times 10/16, which is 100 over 16 times 16 is 256. So that's 100 divided by 256, or over 256, plus, and now I have division here, of 1/5 divided by 3/10. I change it to multiplication, do my reciprocal, and there I am. Now I can do that multiplication, and I still have my 100 over 256, plus, that's just 10 over 15. Now to continue this in this manner, we need a common denominator. One trick is simply to take this and multiply it by this 15 over 15, and this, multiply it by the denominator over the denominator. So I get 1,500 over what? 256 times 15, 3,840 plus 3,560, and this is going to be again 3,840. So adding this together, I get 4,060 over 3,840. And again, it can be reduced but we'll leave it there for now. Okay, let's look at another one here. I'm going to apply the rules for the order of operations. So 3/5 plus 2. Well, if a whole pie has 5/5, then two pies would have 10/5. So this becomes 3/5 plus 10/5 times. And then here we can do the same thing we did last time. This is equivalent to 8/10, right? Multiplying by 2/2. And then we multiply this by 5/5, and we have 5/10. And dividing by 11/15. So we'll bring that down for now. So this is going into parentheses. I have 13/5 times, and here is 3/10 squared divided by 11/15. So squaring my 3/10, I get 3/5 times 9, 3 squared over 100, 10 squared. Then again, I'm dividing by 11/15. Okay, now we do multiplication and division and have the same, are on the same level. So we do them from left to right. So 13 times 9, 117 over 100. And again, there we are. Now we're going to take our 117 over 100, going to change division to multiplication, and we're going to take the reciprocal, and then we multiply. This is 11. And 117 times 15 becomes 1,000. Come on. 1,755. Sorry about the technical difficulty. All right. So now we're going to talk about density property of rational numbers. Between any two rational numbers, there is another rational number. This is called the density property of rational numbers. So finding a rational number between any two rational numbers is very straightforward. Add the two rational numbers, divide that result by 2. The result is always a rational number that follows what we know about rational numbers. If two fractions are added, then the result is a fraction. Also, when a fraction is divided by a fraction and 2 is a fraction, then we get another fraction. This two-step process can give a rational number provided the first two numbers were rational. So demonstrate the density property of rational numbers by finding a rational number between 27/13 and 21/10. So first we need to add them together. So we need common denominators. I can do multiples and do it, or I can just do 10/10 here. That's 1, right? And same here, 27/10. I can do 13/13. That's 1 as well. So this becomes 270/130. And this becomes 21 times 13, 273 over 130. So actually, we can just look at it and tell there's a number between them. But it says to add them up. So when we add these up, I get 543 over 130. If I divide by 2, that's 2 over 1. So it's the same as taking 543 over 130 and multiplying it by 1/2. It's 543 over 260. And that would be a number between the two. All right, let's look at some applications here. Ashley wants to study for 10 hours over the weekend. She plans to spend half the time studying math, a quarter of the time studying history, an eighth of the time studying writing, and the remaining eighth of the time studying physics. How much time will she spend on these subjects? So what is half of 10? So looking at math, 10 hours, and we're going to spend half the time. So that's 10 times 1/2, 5. Okay, a quarter of the time studying history. So that's 10 times 1/4, which is 10/4. And that is history. An eighth of the time studying writing. So writing would be 10 times 1 over 8, or 10 over 8. And the remaining eighth on physics. And we know that this is also 10/8. And if we were to add all those up, we should get 10 full hours. No, this is what, 20 over 8, and this is 40 over 8. If I take 40 plus 20 plus 10 plus 10, divide that by 8, I have 80 over 8, which is 10. So we got it right. Okay, Danny, a nutritionist, is designing a diet for her client. Danny determines that Caleb's diet should be 30% protein. If Caleb consumes 2,400 calories per day, how many calories of protein should Danny tell Caleb to consume? Okay, remember, percentages is parts of 100. So 30% is essentially 0.30, or 30 over 100. So using my calculator, I can do 2,400 times 0.30. Doing it by hand, I can do 2,400 with an understood denominator of 1 times 30 over 100. So 2,400 times 0.30 equals 720. 2,400 times 30 equals 7,200 over 100. And of course, you can divide both by 100 and get, sorry, another 0 on there. So we can divide both by 100 and get 720 as well. It works either way. Okay. Now we're going to use fractions to convert between units. Common application of fractions is called unit conversion, or converting units, which is the process of changing from the units used in making a measurement to different units of measurement. To convert between units, the two equivalent values are made into a fraction. To convert from the first type of unit to the second type, the fraction has the second unit as a numerator and the first unit as a denominator. So 1 mile is equal to 1.60934 kilometers. 1 mile is 1.60934 kilometers. Okay, we did this backwards of how they said it. It'll actually work either way, but so we have 1.60934 kilometers to 1 mile. And we want to know how many kilometers are 200 miles. So what happens here is we multiply across. I get 1.60934 times 200 equals 321.868 over 1. And what happens, since I have mile in the denominator here and mile in the numerator here, that cancels out and I'm left with the unit of kilometers, which was my point. And it looks like I got ahead of myself. So it's known that 4 quarts equals 3 point do you have? So I have 3.785 liters to 4 quarts. And I have 25 quarts. So now I know the quarts are going to cancel out. Do my multiplication, 3.785 times 25, and I get 94.625. Multiply my denominators. Don't forget we have a 4 here instead of a 1. 4. Then simply divide by 4. And I have 23.65625 liters. Okay, as I said, I got a little ahead of myself. A percent is a specific rational number that is literally per 100. In percent, denoted in percent, is the fraction n over 100. So rewrite this as fraction. 4% would be 4 over 100. 50% would be 50 over 100. Rewrite the following percentages in decimal form. So 14% is 14 over 100. So in decimal form, that's 0.14. Same here, 7% is 7 over 100. Decimal form 0.07. Now notice, from 14, 0.14, what did we do? We simply move the decimal 2 places left to convert from percent to decimal. So that brings us to n percent of x items is n over 100 times x. The x is referred to as the total. The n is referred to as the percent or percentage. And the value obtained from n over 100 times x is the part of the total and is also referred to as the percentage of the total. So what is 25% of 1,200? 25% of 1,200. Well, 25 times 1,200 is 30,000. And this is 1, so 100. So we know it is 300. We can factor out 100, both of them. Okay, how about 53%? 53 times 100 over 100 times 1,588 over 1 Understood. 53 times 1588 gives me 84164 over 100, which if we want that in decimal form, right there. So if we know that n percent of the total is x, then the total is 100 times x divided by n. So what is the total? What is the total if 25% of the total is 30? So we have 100 times 30, right? Total is 30 over n, the percentage, 25. So this is what? 3,000 over 25, which is 120. What is the total if 45% of the total is 360? So here I have 100 times 360 over 45. I got 36,000 divided by 45. 36,000 divided by 45. And I get 800 is the total. Okay, our next formula, percentage n of b. That is a times b times 100, or a divided by b times 100. So if our total is 1,000, percentage of the total is 70. So we take 70 over 1,000 times 100. And that is 7%. Here we take, total is 500. 500. Percentage is 4 of the total is 425 times 100. 425 divided by 500 times 100. And we get 85%. Okay, let's look at a few examples here. Riley has a daily calorie intake of 2,200 calories and wants to take in 20% of their calories as protein. How many calories of protein should be in their daily diet? So the total is 2,200. The percent is 20 times 100. And we get 20 times 20 times 100 divided by 2,200. 20 divided by 2,200. Yep. So I get 90.90990. So the percentages we'd round it to. That's not right. I missed by one. It's 9.0909. There we go. Times 100. So we go 9.1%. A small town has 450 registered voters. Total is 450. 54 voted. What is the percentage of registered voters in the town that voted? Times 100. 54 divided by 450 times 100. And that is 12%. A store declares a deep discount of 40% for an item, which they say will save $30. What was the original price? So we don't know. We don't know the original price. But we know the part, and we'll just call the unknown x times 100 equals 40%. So we're going to convert 40% to 0.40, or we're going to divide both sides by 100%. We get 30 times x equals 0.40. Then we're going to multiply by x on both sides, and we get 30 equals 0.40x. And then we're going to divide both sides by 0.40. 30 divided by 0.40 equals 75 is what the original price is. So that's saying 40%. So 30 over 75 times 100 should equal 40. 30 divided by 75, 0.4 times 100 does equal 40. So yes, our answer is correct. And that is all we have for rational expressions.